Okay, in this class I'm going to look at solving basic trigonometric equations. Just before I do, if you pause your video there and just find with your calculator the sine of all these angles, of course you shouldn't really need your calculator. But if you do, type them into your calculator, make sure you're in degree mode. What you'll find is that every single one of these angles, every single angle, the sine is equal to a half. Every single one, all the way down, every single one is equal to half. And again, all these in, every single one of those is equal to half. And I could keep going on, forever and ever. The point is that the sine of infinitely many different angles has a value of a half, because of how sine is defined. Remember, sine is defined as y over r in the coordinate plane. The sine function is defined as y over r. So anywhere where the y coordinate divided by r is equal to half, the sine of that angle will equal to a half. So I take anywhere, for example, 2 units away from the origin, where the y coordinate is 1. If that's 2, that's 1. The sine of that angle is going to be 1/2. But, there's infinitely many angles that are coterminal with that. So suppose I went around, all the way around through 360 and then back to here and back there. There's another angle that has a sine equal to a half. Okay. Now type your sine inverse function into your calculator, sine inverse of 1/2, and it will tell you that your answer is 30. It doesn't say that there's infinitely many answers, because they're not. The sine inverse of 1/2 is 30 because of how we restrict the domain and the range for the sine function. It's only a function if when I plug in one value I can get one value out. So what we do is we restrict the domain and the range. The domain is the numbers I'm allowed to get out, and the range is the numbers I'm allowed to, the domain is the numbers I'm allowed to put into the function. The range is the numbers I'm allowed to put out. So for the sine inverse function, any number from -1 to 1 can go into the sine inverse function. So if you type into your calculator sine inverse of 2, your calculator will tell you you've made an error, because you're not allowed to put 2 into your domain. It can't go into the sine function. Only numbers from -1 to 1. The square brackets mean -1 is included and 1 is included. And your range are the numbers you will get out. The range from -pi/2 radians to pi/2 radians. If I was to put that in degrees, -pi/2 will be -90 degrees to 90 degrees. So anytime you type sine inverse of a number in, the number has to be between -1 and 1, and the output you will get out will always be between -90 and 90, or -pi/2 and pi/2. For the cosine function, the domain again is -1 to 1. So if you try to type in cosine inverse of 5, your calculator will tell you that's an error, because it's not between -1 and 1. Square bracket means -1 and 1 are included in this domain. And then the range, cosine inverse of any number you put in, will always be between 0 and pi. In degrees, that will be between 0 and 180 degrees. Remember, pi radians is equal to 180 degrees. For the tan function, the domain is all the real numbers. You can plug any real number in here, going from -infinity as low as you like up to positive infinity as high as you like. Round brackets here because they're not actually included real numbers. Infinity isn't an actual number. Your range will be all the numbers from -pi/2 to pi/2, which will be -90 degrees to positive 90 degrees. Notice the round brackets here, because 90 and -90 are not included in this range. Okay, all the numbers between -90 and 90 can come out of the tan inverse function, but 90 and -90 cannot. So round brackets saying they're not included, square brackets saying they are included. And these are well worth remembering. The domain and the range. The domain is the numbers I'm allowed to put in. The range is the numbers that I can possibly get out. Okay, so you will never get, say, cosine inverse of some number will never ever give you 181. It's always between 0 and 180. Okay? So we'll come back to a minute. So if I was to ask what's cosine inverse of root 3 over 2, even though there are infinitely many angles whose cosine is root 3 over 2, cosine inverse of root 3 over 2 has to be between 0 and 180, and the only angle between 0 and 180 where the cosine is root 3 over 2, notice positive, it'll be in the first quadrant, the only angle that can be is 60 degrees. However, there are infinitely many angles whose cosine is 60 degrees. Infinitely many angles whose cosine is root 3 over 2. For example, 60 degrees, 420 degrees. Okay, so let's look at a basic trigonometric equation. Here I have the question that says the sine of x equals negative 1/2. We want to solve this thing, and x has to be between 0 and 360 degrees. So solve this thing. Solve this equation is what we're being asked. So a couple of things to understand. The first thing we always want to do is identify the domain. Okay? So the domain, what is the domain? Well, there's a restricted domain. Generally with the sine function you can plug any number into it. You can find the sine of any number. The sine inverse function, remember, the domain can only be between negative 1 and 1. But for the sine function, any number can go into it. However, they're giving me a restricted domain. They're telling me x has to be between 0 and 360. So sine of x is negative 1/2. Remember, that's the y coordinate divided by r. So the y coordinate would have to be negative 1, and it'd have to be 2 units from the origin. The first thing is to identify the domain. The domain here is this. It's given. It's between 0 and 360 degrees. In general, the domain for the sine function is all real numbers. However, in this question, they're restricting it. They're saying we want to find the values of x that are between 0 and 360 that I can plug in here, where the answer will be negative 1/2. Okay, so that's essentially what the question says. Find the values of x, but they have to be between 0 and 360, where when I plug them into the sine function, the outcome is negative 1/2. The second thing is to identify the quadrant and the reference angle. Okay, and we identify our quadrant using this kind of memory tool that we've spoken about. All trig functions have positive ratios in the first quadrant, only sine and its reciprocal in the second quadrant, only tan and its reciprocal in quadrant 3, and only cosine and its reciprocal have positive ratios in quadrant 4. To identify the reference angle, well, remember, if sine of x is some number, then sine of the reference angle will be the absolute value of that number. The reference angle is always an acute angle. The sine of any acute angle is always a positive thing. Okay, then we just roughly sketch and deduce our answer. Once we've done those first couple of things, it's really plain sailing. Okay, we just have to think logically. Okay, so we're going to try to solve this thing. The first thing is identify the domain. The domain is given, you know. The domain, let me write it out here. The domain is x belonging to the interval from 0 degrees to 360 degrees. Okay, so any number between 0 and 360 degrees could be the answer here. So we're going to narrow it down by identifying the quadrant. So sine of x is negative 1/2, and we know that the sine of x is negative in quadrants. Okay, well, we look up here. All functions are negative, or net positive in the first one. Sine is positive in the second one. So sine is negative in there because only tan is positive, and sine is negative also in there. So sine is negative in quadrants 3 and 4. So I've identified the domain. I've identified the quadrant, and now I want to find the reference angle. So sine of x is negative 1/2. Well, that means sine of the reference angle is the absolute value of negative 1/2. It's positive 1/2. So sine of the reference angle is positive 1/2. I want to identify the reference angle. The sine of what angle is positive 1/2? So to find the reference angle, you probably know it already if you know your special angles. But if you don't, and you have a calculator, you can just type in the reference angle will be sine inverse of 1/2. Okay? The sine inverse of 1/2. And you plug that into your calculator, you'll find the reference angle is 30 degrees. I should, of course, identify that the domain is given in degrees, so my answer has to be degrees. I'm not dealing with radians here. So my reference angle is 30 degrees. Again, going through my steps. First thing, identify the domain, all the numbers from 0 to 360. Identify the quadrant and the reference angle. We saw that sine was negative, therefore in quadrant 3 and 4. Sine of the x is negative 1/2, so sine of the reference angle is positive 1/2. Working that out, we can figure out that the reference angle has to be 30 degrees. Now finally we're going to sketch and deduce an answer. So we're going to draw. Remember, we're dealing with quadrants 3 and 4. We're dealing with a reference angle of 30 degrees. So reference angle of 30 degrees, there's quadrant 3. Quadrant 4, reference angle 30 degrees. There we are. The angle x could be either this angle all the way around here, or this angle all the way around here. So we just have to deduce what are those angles. So remember, there's 0 degrees, 90 degrees, 180, and this is going to be 180 plus 30. So x in this case would be 180 degrees plus 30 degrees. And over in the second case, we've got 0 degrees, 90, 180, 270. Around here will be 360, but we're going 30 degrees less than 360, so hopefully you can see that x in here will be 360 degrees minus 30 degrees. So therefore, x can be one or two things, okay? It's either 210 degrees or 330 degrees. And they're the two angles. Sometimes you see that written in set notation. X belongs to the set brackets here, chain brackets important, containing the elements 210 degrees or 330 degrees. So x could be one of those two things. And again, type those in, check your answer. How do you check your answer? Well, you first of all check, are those answers fitting into my domain? Yes, they're both between 0 and 360. And check, is sine of the angle equal to negative 1/2? Okay. Really common error with this question is people just take it and write in sine inverse of negative 1/2. That is not giving me my answer because it's not giving me all my possible values between 0 and 360. Note, let me just type in sine inverse of negative 1/2 into my calculator, and your calculator tells you it's negative 30 degrees. Notice negative 30 degrees does not come up in here. Okay, but negative 30 degrees, notice there's a negative 30 in there. That's that. And why is my calculator telling me negative 30? Well, your calculator will always tell you values between negative 90 and 90. Okay, so your negative 30 fits in there nicely. However, it doesn't say find sine inverse of negative 1/2. It says if sine of some angle between 0 and 360 degrees is negative 1/2, then find that angle. Okay, and there are two of them, 210 or 330 degrees. So follow the steps. All of these can be solved in the same way. Let me look at another example here. Cosine of x is negative root 3 over 2. Here my domain says 0 is less than or equal to x, which is less than or equal to 2 pi. So I have to work this out in radian mode. Okay, so if you're using your calculator, make sure the first thing you do is change your calculator to radian mode. On my calculator, I do that by hitting shift, setup, press number 2 for the angle unit, and then number 2 for radians. Okay, but you'll have to figure out your own calculator if you have a different one to mine. So cosine x equals negative root 3 over 2. This is my domain. Step 1, identify the domain. So the domain here is x has to belong to the interval starting at 0 and finishing at 2 pi. Okay, including, notice square brackets here saying including 0 and 2 pi because it's a less than or equal to sign. So 0 is included, 2 pi is included. That's my domain. If you prefer to use it an inequality as opposed to interval notation, feel free, whatever you prefer. So that's my first thing, I'm identifying the domain. The second thing is to identify the quadrant and the reference angle. So cosine of x is negative root 3 over 2, so I'm just going to say cosine of x is negative in quadrants. Again, you can use your little memory tool and you'll see that cosine is positive in quadrants 1 and 4, so cosine is negative in here in quadrant 2 and in here in quadrant 3. So cosine is negative, that means we're dealing with quadrant 2 and 3. The next thing is to find the reference angle. And again, to find the reference angle, I'm going to say, well, cosine of x is given as being negative root 3 over 2, which means that cosine of the reference angle will be the absolute value of that, positive root 3 over 2. Okay, and you should really know what reference angle will give you root 3 over 2 when you plug it into the cosine function. I know it already, I know it's 30 degrees, but if you don't, type into your calculator cosine inverse of root 3 over 2. Cosine inverse of root 3 over 2 is 30 degrees, or if we're in radian mode, that's going to be pi over 6. Okay, so depending, again, you can use both as long as you give your final answer in radians. You can use degrees along the way. I'm going to use radians, but you could say 30 degrees at this stage. My final answer ultimately has to be in radians, but if you prefer using degrees, feel free at this stage using your reference angle, no problem. Okay, so now I've found my reference angle is pi over 6 radians, or 30 degrees. I know I'm in quadrant 2 and 3. Now I'm going to sketch. So sketch and deduce. So sketch quadrants 2 and 3. So in quadrant 2, reference angle of pi over 6. Quadrant 3, reference angle pi over 6. If you prefer to stay with degrees for the moment and then convert into radians at the end, that's fine. I'm not going to do that. Remember, a straight angle around to 180 degrees, that's 0 radians, pi over 2 radians, pi radians. So this is, in this first one, the angle we're looking for here, x, well, it's going to be pi radians, but subtract pi over 6. So x would be pi radians, subtract pi over 6. In this quadrant in here, x would be pi radians plus pi over 6. So x is going to equal to, pi is just 6 pi over 6, so 6 pi over 6 minus 1 pi over 6, that's 5 pi over 6. And pi plus pi over 6, well, that's 6 pi over 6 plus 1 pi over 6. That's going to be 7 pi over 6. So there's my answer. It's one of those two things. If you prefer set notation, again, you can write that x belongs to the set containing the elements 5 pi over 6 and 7 pi over 6. So either of those answers is good. So you can write it like that or like that, depending on personal preference. If you wanted to work it in degrees all the way down, and then when you have your final answer in degrees, well, you just convert it into radians at that stage. Okay, so you'd find this would be 150 degrees, this would be 210 degrees, multiplied by pi over 180 to convert into radians. Okay, so solving, same few steps all the time. Let's look at one with the tan function. Again, the same thing. Start by identifying the domain. I want to solve this equation. Tan of theta is root 3. Notice theta has to be between 360 and 720. So theta belongs to the interval starting at 360 and finishing at 720. Why square brackets? Because 360 is included, because it's a less than or equal to. That's step 1, identify the domain. Step 2, identify the quadrant, and then the reference angle. Okay, well, to identify the quadrant, tan is positive here. Tan of theta is positive root 3, so we know that tan is positive in quadrants. And again, if you're unsure, you should know this stuff. If you're unsure, have a quick look here. Tan is positive. Well, all functions have positive ratios in quadrant 1, and only tan and its inverse, or its reciprocal, I should say, have positive ratios in quadrant 3. So we're dealing with quadrants 1 and 3. The reference angle, well, tan of theta is equal to root 3, which means the tan of the reference angle is also equal to root 3. Remember, the absolute value of a positive number is just that number itself. The absolute value of a negative number is the opposite of that number. Okay. I'm also in degrees here, so one thing I'm going to make sure if I'm using a calculator, which I shouldn't really need to use if I know my special angles well enough, but I'm using a calculator. If I'm using a calculator, I want to make sure it's in degree mode. Okay, so on my calculator, put it in degree mode. It's shift setup, and then number 2 for the angle units, and number 1 for degrees. Okay. So you should know this. If you don't, you just type into your calculator. The reference angle is going to be tan inverse of root 3. Okay, so tan inverse of root 3 into your calculator. You'll find that the reference angle is 60 degrees. Okay. So we've identified the quadrant, we've identified the reference angle, we've identified the domain. Now we want to go and sketch. Okay, so two quadrants here. Just a rough sketch will do. Either in quadrant 1 with a reference angle of 60 degrees, well, there is quadrant 1 with a reference angle of 60 degrees. Or quadrant 3 with a reference angle of 60 degrees, there's quadrant 3, reference angle of 60 degrees in there. Write that in again, it's a little, doesn't look great. Maybe I'll make my pen a little narrow, so 60 degrees in there. Okay, and I'll do the same with this one. It's just a little difficult to see at the moment. So 60 degrees in there. Okay. So to sketch my angle, note it has to be bigger than 360 and less than 720. So more than one full circle around, but less than 2. So 60 degrees is not going to be one of my solutions. But if I start here, go all the way around, remember this is going to be whatever x is here all the way around, and then back to here, that's going to be my angle. And that is a full 360 plus that 60 degrees. Over here, we'd be going all the way around, past 360, and then remember this is what x is, all the way around to there. So we're going 360, and then another 90, 550, 450 I should say, and then another 90, 540, and then 60 more, which is 540 plus 60 degrees. Okay, and then just to phrase my answer, therefore x is equal to 420 degrees or 600 degrees. Check your answer. How do you check your answer? Well, you check a couple of things. First of all, you check, does it satisfy the domain? Are those values for x bigger than 360 and less than 720? Yes, they are. And if I type them into my tan function, tan of 420, you can try this in your calculator, is root 3. Type in tan of 600. It is root 3. There's my solutions. Okay? So that's how we solve basic trigonometric equations. In our next class, we'll look at solving trigonometric equations with coefficients in the arguments. But practice those, see how you get on.